All right, good day. Hope that you're doing well. So in this video, we're going to be doing it questions based on geometry. And to be specific, our main focus is going to be on similarity as well as congruency questions, right? Now, starting off with the first question, we are given this diagram here, and they're telling us that this line AB is equals to AD as well as BC. BC is going to be equals to DC, right? Now, can you see the kind of shape that is here? The first question wants us to name the kind of quadrilateral that ABC is, right? ABCD rather. Now, this is a kite. And in order to be able to answer most of these questions relating to this diagram, you need to know the properties of your kite, right? Now, what are the properties of a kite do you need to know? Now, let me just try and make a rough sketch of a kite on the side, right? Because on this original sketch, this is where I'm going to do my workings based on the questions that are being asked. So here, if I were to draw my rough sketch of a kite, now, if this is a kite, I know the diagonals of my kite, they meet at 90 degrees, right? So the diagonals of my kite, they're going to meet at 90 degrees. And I know that these two angles are going to be equals to D. Basically, angle B is going to be equals to angle D, right? So now, what else do I know about my kite? I know that the angles in my kite are bisected. What do I mean? These angles are cut into two equal angles. So as a result, I know that this here is going to be equals to that, right? Because these angles are bisected. And I also know that this angle here is going to be equals to that angle, right? Now, taking into consideration that, let us try and answer the following question. Now, we need to prove that triangle ABC is congruent to triangle ADC. Now, let me look at my triangle ABC. Let me try and highlight it. So triangle ABC is the triangle I've highlighted in green, and the other triangle, let me try and highlight it with a different color, which is blue. And triangle ADC is the triangle below it. Now, how can I prove that these two triangles are exactly the same? I need to find three things which are equal in those two triangles, right? But then it's important, right? So this mustn't be in terms of angles, right? For example, I must not prove that all the angles in triangle ABC are equal to all the angles in triangle ADC, because if I was doing so, I would have been proving similarity. Remember, in similarity, you're going to prove that the angles in one triangle are going to be exactly the same as the angle in the other triangle, right? So here, we're not proving that all angles are equal. But taking that into consideration, I'm going to first start by mentioning that this angle here, it is equals to that angle, right? So angle B is equals to angle D. Now, what is the other point I can mention? So now, the other point I can mention, now, remember, everything must not be in terms of angles, right? As I've illustrated in this diagram, I know that this angle here, A1, is going to be equals to angle A2, right? Because why? Angles of your kite are bisected. So now, this is another point that I'm going to mention. A1, it is equals to A2, right? And why is that? These are angles bisected by your diagonals of your kite. Why is that? Because this angle is bisected by the diagonals of your kite. Now you could use it different points as long as you do not prove that all angles here in the green triangles are equal to all angles in ADC. As I've said that if you were doing so, you would have been proving similarity, right? Now, the last point I could use what I'm given. I'm told that AB is equals to AD, right? These two lines are equal to one another. So I could just say AB is equals to AD, and this is given. That's also another point you could use. Another point you could use is this BC is equals to CD, right? This is just another point that you could use, right? And you would also say given. But here I have my 3 points, so I can go about saying that, okay, these two triangles, triangle ABC, it's congruent to triangle. So this is triangle ABC to triangle ADC. And my reason is going to be, can you see here, I have angle, I have a side, I have an angle also, and I have a side, right? So I can say side, angle, angle. Let's say you used this information here, right? Instead of you saying this, maybe you said BC is equals to DC, and your reason was given. Now you've proved an angle as well as two sides. Your reason would have been side, angle, side, right? Now, that will be all for this question. Now let us move on to the next question. Now in the figure below, we are told that angle C is equals to D and both of them they are equals to 40 degrees. Now we need to prove that triangle CFB, right? So CFB is this triangle at the bottom, the big one. So let me try and highlight it in blue. So triangle CFB in blue, we need to prove that it's similar to the triangle above, which is the small triangle here. So we need to prove that these two are similar to one another. And as I've said, to prove similarity, you need to prove that three angles in those two triangles are exactly the same. Now, whenever you're proving similarity, okay, first let me start by identifying those angles that are equal in the two triangles. Now, can you see that angle F1 and F2, they are vertically opposite. So as a result, what do we know about vertically opposite angles? We know that vertically opposite angles are equal to one another. So here, angle F1 is going to be equal to angle F2, and my reason would be vertically opposite angles. Now, also, angle D is equal to angle C, and this was given, right? Now, lastly, whenever you prove similarity, right, if you could prove that two angles are equal to one another, right, basically here we prove that angle D is equal to angle C, angle F1 is equal to angle F2. Therefore, you can conclude that these or this remaining angle is going to be equal to the other remaining angle in your triangle, right? And why is that? Let's say your F1 had an actual value, right? So if I were to draw, let me just draw a triangle here. This is E, D, F, and the big triangle, I'm just going to draw it here. This is F, B, C. Now, D is 40. Same applies to this is 40. Now, let's say our angle F1 had an actual value. Let's say it was 20 degrees. It means that here it was going to be 20 and here it was going to be 20 because these two are vertically opposite. Now, I want you to note something. Remember, your sum of angles in a triangle, they should be equal to 180, meaning that if I were to calculate E in this small triangle, right, I would say 180 minus 40 plus 20, which is 60. So as a result, my angle E would have been equals to 120. Right? Now, same applies. If I were to calculate B in this big triangle, I would have said 180 minus 40 and 20, which equals to 60. As a result, my angle B would have been equals to 120. Now, this is what I mean when I say when you've proved that two angles are equal in these two triangles, therefore you can conclude that the remaining ones are also going to be equal to one another, right? So here, I'm going to say angle E is equals to angle B. And my reason, I can see sum of angles in a triangle. Hence, I've shown you an example using my sum of angles in a triangle technique. Now, I have proved, now I can conclude that the two triangles, triangle CFB is going to be similar to triangle GFE. And because I've proven three angles, as you would always need to do that whenever you're proving similarity, my reason is going to be angle, 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 right? Now, every time whenever you are asked to prove a similarity question, right, always expect an answer whereby they're going to ask you to determine the length of one side of a triangle, right? As you can see, 4.4.2, they've given us the length of CB, CF, as well as DF, and they want us to calculate the length of ED. Now, whenever I have these kind of questions, always I try to separate my two triangles. So I'm going to draw them separately here, starting off with the small one. And now the big one. Now, they're giving me the length from C to B as 7.5. Now they gave me the length from C to F as 9 centimeters. Now they also gave me the length from D to F as 3 centimeters. Now they want me to calculate the length from E to D. All right. Now, how would I go about doing that? So you would need to make use of your ratios, right? So what do I mean by that? What is the length we're looking for? It's ED. And what is that length that is similar to ED in your other triangle? Right? It's BC. Now, can you see that BC is similar to your ED, right? Because if I were to flip this, let's say I want this big triangle to be in the same position as the small triangle in blue, right? If I were to flip it over, it would have been like this. So let me just do that. Right? So basically my F would have been here and my B would have still remained to be here as well as my C. right? We're just flipping it over so that it could be in the same position as this blue triangle. And now I know that my length from B to C is 7,5, and my length from F to C, it's 9, right? Now, hence I said, what is that side that is similar to ED in this big triangle? It's going to be BC. BC, it is the side that is similar to ED, right? So I'm going to divide this by BC equals to, now, what other side do I have values of? I have the value of my FC, right? In the big triangle, right? I have the value of my FC, and here in the small triangle, I have the value of my DF, meaning that I need to also make use of these sides. So I'm going to start with DF, and the side that is similar to DF in my other triangle, it's FC. As you could see, they are in the similar position, right? So all this divided by your FC. Now, substituting values, I'm looking for ED, so I'm going to write this here. I'm looking for ED divided by my length from B to C, 7,5, and this is equals to the length from D to F, it's 3, divided by my length from F to C, which is 9. Now here, next step is cross multiply. So ED would be multiplied to 9. So this is going to become 9 ED. And this is going to be equals to 3 multiplied to 7,5, which is 22,5. Now I'm looking for ED, not 9 ED. And because this 9 is multiplying, to get rid of it, I'm going to do the opposite of what it does, which is dividing. And what I do on the left, I must also do on the right. So as a result, my line ED would be equals to 22,5 divided by 9, which is equals to 2,5 centimeters. And this would be your final answer. Right? And that'll be all for this video. Remember, if ever you have any questions, always feel free to reach out. Thanks.